Factors contributing to circuit breaker non-tripping include the modified sine wave inverter. Modified sine wave inverters produce waveforms that are not as smooth as pure sine waves. This can cause distortion in the current, potentially affecting the operation of circuit breakers. The overload protection or opt type must also be considered. Circuit breakers are designed to trip at specific current thresholds. It's possible that the circuit breaker used in this case was not rated for the current demand. Poor quality circuit breakers may also cause issues. In some cases, defective or low-quality circuit breakers may not trip properly due to manufacturing faults or degradation over time. Loose connections may also be a factor. Loose or damaged connections can increase resistance in the circuit, potentially reducing the current flow through the breaker and preventing it from tripping. Harmonics can also negatively impact circuit breaker operation. Modified sine wave inverters can introduce harmonics into the electrical system, which can further distort the currents that affect circuit breaker performance. Aging circuit breakers can also cause problems. Over time, circuit breakers can wear out or become less sensitive, reducing their ability to trip at the rated current. The non-tripping of the opt in this scenario poses a significant safety concern. Ground faults can occur if the insulation between the live conductors and the ground is compromised, potentially leading to electrical shock or fire. It is recommended to contact the solar installer to investigate the issue and consult with the inverter manufacturer. If necessary, replace the circuit breaker with a higher rated one. Ensure all electrical connections are tight and secure. Regularly inspect and replace aging or defective circuit breakers. Consider installing a ground fault circuit interrupter or GFCI to provide additional protection against ground faults. It is important to understand how circuit breakers operate. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset, either manually or automatically, to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect an individual household appliance up to large switchgear designed to protect high-voltage circuits feeding an entire city. All circuit breakers have common features in their operation, but details vary substantially depending on the voltage class, current rating, and type of the circuit breaker. There are three main types of circuit breakers: thermal, magnetic, and solid-state or hybrid. Thermal circuit breakers operate using a bimetallic strip that heats up and bends when excessive current flows through it. This bending action trips the breaker. Magnetic circuit breakers use an electromagnet that trips the breaker when excessive current magnetizes it. Solid-state circuit breakers use electronic components to detect overcurrent conditions and trip the breaker. The tripping characteristics of a circuit breaker are defined by its time current curve. This curve shows the amount of time it will take for the breaker to trip at different levels of overcurrent. The curve is designed to protect the circuit from damage caused by overcurrents, while also allowing for short-duration inrush currents that are common when starting motors or other inductive loads. Circuit breakers are rated by their continuous current carrying capacity and their interrupting capacity. The continuous current carrying capacity is the amount of current that the breaker can carry continuously without tripping. The interrupting capacity is the maximum amount of current that the breaker can safely interrupt. Circuit breakers are tested to ensure that they can meet these ratings. When selecting a circuit breaker for a particular application, it is important to consider the following factors: the voltage and current rating of the circuit, the type of load being protected, the interrupting capacity of the breaker, and the environmental conditions in which the breaker will be used. The National Electrical Code, or NEC, provides guidance on the selection and installation of circuit breakers. Article 240 of the NEC covers overcurrent protection. This article provides requirements for the selection, installation, and protection of overcurrent devices, including circuit breakers. Section 240.4 of the NEC covers the protection of conductors. This section requires that conductors be protected against overcurrent in accordance with their ampacities. The ampacity of a conductor is the maximum current that the conductor can carry continuously under specific conditions of use without exceeding its temperature rating. Section 240.6 of the NEC covers standard ampere ratings for fuses and inverse time circuit breakers. This section lists the standard ampere ratings for fuses and circuit breakers, which are typically available in sizes ranging from 15 amps to 6000 amps. Section 240.21 of the NEC covers location in a circuit. Overcurrent protection shall be provided in each ungrounded circuit conductor at the point where the conductors receive their supply. Section 240.85 of the NEC covers applications of series-rated circuit breakers. Circuit breakers can be series-rated, which means that they are used in combination with other circuit breakers to provide overcurrent protection. Series ratings are based on the interrupting capacity of the circuit breakers. When using series-rated circuit breakers, it is important to ensure that the circuit breakers are properly coordinated to prevent nuisance tripping. Coordination studies are typically performed to determine the appropriate settings for the circuit breakers. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. A GFCI is a device that detects ground faults, which occur when current leaks from a circuit to ground. When a GFCI detects a ground fault, it quickly interrupts the circuit to prevent electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FCIs, are designed to protect against fires caused by arcing faults. An arcing fault is a dangerous condition that can occur when electricity jumps between two conductors. FCIs are designed to detect arcing faults and interrupt the circuit to prevent fires. FCIs are required in many locations, such as bedrooms and living rooms. Surge protective devices, or SPDs, are designed to protect electrical equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other events. SPD are designed to divert voltage surges away from sensitive electrical equipment to protect it from damage. SPD are available in a variety of types and sizes. It is important to select an SPD that is appropriate for the application. Regular maintenance of circuit breakers is essential to ensure that they operate properly. Circuit breakers should be inspected regularly for signs of damage or wear. The connections to the circuit breaker should be checked to ensure that they are tight. Circuit breakers should also be tested periodically to ensure that they trip properly. Testing can be performed using a circuit breaker tester. If a circuit breaker fails to trip properly, it should be replaced immediately. In addition to the factors mentioned previously, there are a few other things to consider when troubleshooting circuit breaker problems in systems with modified sine wave inverters. The type of wiring used in the circuit can affect circuit breaker performance. For example, if the wiring is undersized, it may not be able to handle the current demand of the load, which can cause the circuit breaker to trip. The ambient temperature can also affect circuit breaker performance. Circuit breakers are typically rated for operation at a specific ambient temperature. If the ambient temperature is too high, the circuit breaker may trip prematurely. The altitude can also affect circuit breaker performance. At higher altitudes, the air is thinner, which can reduce the cooling capacity of the circuit breaker. This can cause the circuit breaker to overheat and trip prematurely. When troubleshooting circuit breaker problems, it is important to gather as much information as possible about the problem. This information can include the type of load being protected, the size of the circuit breaker, the type of wiring used in the circuit, the ambient temperature, and the altitude. Once you have gathered this information, you can use it to narrow down the possible causes of the problem. One common problem with modified sine wave inverters is that they can generate harmonic currents. Harmonic currents are currents that are multiples of the fundamental frequency of the AC power supply. These harmonic currents can cause a variety of problems, including overheating of electrical equipment, increased energy consumption, and interference with electronic devices. Harmonic currents can also affect the performance of circuit breakers. In some cases, harmonic currents can cause circuit breakers to trip prematurely. In other cases, harmonic currents can prevent circuit breakers from tripping when they should. To mitigate the effects of harmonic currents, it is important to use harmonic filters. Harmonic filters are devices that are designed to reduce the amount of harmonic current in a circuit. Harmonic filters can be installed at the load or at the source of the harmonic current. Another common problem with modified sine wave inverters is that they can generate voltage distortion. Voltage distortion is a deviation from the ideal sine wave shape of the AC power supply. Voltage distortion can cause a variety of problems, including reduced efficiency of electrical equipment, increased noise, and interference with electronic devices. Voltage distortion can also affect the performance of circuit breakers. In some cases, voltage distortion can cause circuit breakers to trip prematurely. In other cases, voltage distortion can prevent circuit breakers from tripping when they should. To mitigate the effects of voltage distortion, it is important to use voltage regulators. Voltage regulators are devices that are designed to maintain a constant voltage level. Voltage regulators can be installed at the load or at the source of the voltage distortion. It is also important to consider the grounding system when troubleshooting circuit breaker problems in systems with modified sine wave inverters. The grounding system is the path that provides a return for fault current. A properly designed grounding system is essential for protecting people and equipment from electrical shock and fire. The grounding system should be designed in accordance with the requirements of the National Electrical Code. When troubleshooting circuit breaker problems, it is important to check the grounding system to ensure that it is properly installed and maintained. One of the most important safety devices in any electrical system is the ground fault circuit interrupter, or GFCI. A GFCI is a device that is designed to protect people from electrical shock. GFCIs work by monitoring the current flowing through a circuit. If the current flowing through the circuit is not equal to the current returning to the source, the GFCI will trip and interrupt the circuit. This can happen if someone comes into contact with a live wire or if there is a ground fault. GFCIs are required in many locations such as bathrooms, kitchens, and outdoor areas. It is important to test GFCIs regularly to ensure that they are working properly. Another important safety device is the arc fault circuit interrupter, or FSI. An FSI is a device that is designed to protect against fires caused by arcing faults. Arcing faults can occur when electricity jumps between two conductors. This can happen if the insulation on a wire is damaged or if there is a loose connection. FSIs work by monitoring the current flowing through a circuit. If the FSI detects an arcing fault, it will trip and interrupt the circuit. FSIs are required in many locations such as bedrooms and living rooms. It is important to test FSIs regularly to ensure that they are working properly. Surge protective devices, or SPDs, are designed to protect electrical equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other events. SPD work by diverting the excess voltage away from sensitive electrical equipment. SPD are available in a variety of types and sizes. It is important to select an SPD that is appropriate for the application. In addition to the safety devices mentioned above, there are a number of other things that you can do to protect yourself from electrical hazards. Always use caution when working with electricity. Never work on electrical equipment while it is energized. Always disconnect the power before working on electrical equipment. Use properly insulated tools. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. Following these safety precautions can help to protect yourself from electrical shock and fire. Always consult with a qualified electrician before making any changes to your electrical system. Electrical work can be dangerous, and it is important to have it done by someone who is trained and experienced.